So our marketing department has come across a need in the market out there to produce a calibration equation for Coco Fibre. A lot of people are working in Coco Fibre as a growth media for their plants, and we don't currently have a calibration. We've just got one at the moment, really, just because we've worked that out in the last few months. But the way that we do that is essentially obtain some Coco Fibre material, and this is the sort of raw material that we get. It comes in all sorts of textures. It comes with quite large lumps and some very fine sort of peat material. So we need to know some of the specifications of exactly what that Coco Fibre is. This is called IrriMAX, IrriMAX brand there. That is just one slab. When you wet that up, it increases to about 10 times the volume. So it's quite a large volume in that section there. So we need to wet that up and then put it into a tray. That goes into a tray where we wet it up with some water, essentially. This is just, I generally use pure water, as pure as I can get it, and then mix it through. And then put it into this is a column that I prepared earlier. This column has already got some Coco Fibre in there. It's also got a base of sand and some diatomaceous earth at the very bottom. That's so that we can get really good flow. We can get really good flow through the column, uninterrupted, and we get consistent flow. So to prepare that, essentially, no high science to it all. It's just a matter of packing some material. And we stomp it down with something like this. It's just a hand or manual stomping, just to get something that's going to be comparable to what's in the field. And once we're satisfied with that, we will install a single sensor. So single sensor, in this case, you could use a 30 centimetre sensor if you wanted to, but as long as you've got the right depth, you've got to have complete coverage of the sensor, so that you haven't got anything exposed to the air, because once you have exposed to the air, the sphere of influence will go into the air and you'll get lower values throughout the probe. So for the single sensor, it's really easy. You've only got one depth to worry about. I use a tool here, just fashioned from the casing of a drill and drop, and that's just to make a hole in my material. What I do, looks very delicate, just making a hole there and putting the single sensor in, and then I'll pack that around just to get good contact, and then I would check on the phone to make sure that I can speak to the probe, the single sensor, and that I'm getting good values. Make sure that I've got the water content values, the salinity content, and the temperature. You need all of those values for the test to be valid. Okay, so I would leave that for a period, perhaps just maybe half an hour to let it settle. The water content, you actually do a download, have a look at the data, see if the signal is nice and flat. If it's nice and flat, then it means that you can start sampling. So when you're sampling, you basically write down exactly what time it is that you're doing the sampling. The sampling is done with a a volumetric ring. So this is a ring. It's made of brass. It's got a chamfered edge. It's got a blade on one side. That's a sharpened edge, and on the other one is just flat. So I know the volume of that, and I've got a series of those. These are specially made. They're not just made in a garage. They're specially made to be a consistent volume, and I know what that volume is on each one. So essentially what you're doing is collecting a volumetric sample. So to do that, and you want to do 3 of those samples so that you can at least, if one of them's particularly out, then you can throw that value out. But essentially it's just a matter of teasing the sample container into the soil. In this case it's cocoa fibre. We do that 3 times. This is very soft, but if it's quite difficult, you can use a mallet. So I'll put those 3 in there. Just a matter of thinking it in. And then I have another special piece of equipment here. It's called a block of wood. Just to tap it in. So they're all tapped in. And then we want to extract those 3 rings. So we remove some of the cocoa fibre on one side. So I've got a bent spatula here so that I can go underneath the volumetric sample. So I sort of feel around and feel the bottom of the sampler, and that's part of my sample. The idea is you want to get a consistent volume, so we tease a little bit. You see that okay? Right there. This is the hard one to get because you get a lot of hair. So you want to be quite disciplined with this and get a good sample. So that's our sample. So we bring our sample over to a container. This is an aluminium tray that we can put in the oven. So I'll just make sure that I collect every bit of my sample. Into a tray. And that's labelled, clearly labelled. We bring it into the lab here. We've got a set of scales. It's important to get your readings as soon as you can. I'll do a tare with an empty container. That's my tare. Then I'll put my sample on and I'll write it down with my pen, which I don't have. I'll write that value down. That's the wet weight. So that sample then goes in the oven. The wet weight, got the wet weight, goes in the oven. Just goes in there. We use 105 degrees for drying out a soil sample or a cocoa fibre sample, and we check that with a thermometer. That will be on for the next 7 days. We'll record values of the weight every day until we get a flat value, so that you know exactly that you've got all of the water out. Okay, so if we're ready to take a reading of the weight as it's drying, we use a desiccator like this to place the sample in. That will allow a sealed environment for the sample to come up to temperature. So we take that from the oven. That will go in the desiccator. You'd have 3 or 4 of them. Just put that one on and you close the environment there, and you'll leave that for half an hour to an hour. So to break the seal, you open that up and then take your sample out. Okay, so that goes back on the scales. Again, you're tearing, making sure, yep, that's, I'll press the tear, 0. And after 3 days, that'll be fairly much the dry weight, but we do it for another 4 days after that, just to make sure that all of the large components are completely dry, because some of these components in here, you know, a piece like that will take days to dry. So we make sure that they're all completely dry, and then we process the data from there. So that'll go back into the oven. For another day, and we'll repeat the weighing procedure for the next 7 days until we get a dry value. Right, so all of those weights, they go into a Excel sheet. You can see we've collected them all for 7 days there, and then we graph, we do the calculations, calculate the volumetric water content, and we end up with a calibration equation. So what we did was we started at the wet end. We had a lot of readings in the wet end to begin with. Then we pushed it even wetter, and then we dried it out. So you've actually got to cover as many water contents as you possibly can, so that you can get a really good R-squared value. This is a function that's calculated through Excel. You can set the different equations that you might select, and you get an R-squared value that shows you how good this line is. This line that is put in along all of the points in the best fit that it can be, and that R-squared then reflects how well that occurs. So that's how we generate one curve. That took us perhaps 2 weeks to produce. We got a really nice R-squared, 0.95, 0.96. So we're happy with that. And we can do that now for any particular mix that you have. There might be 100% organic matter, or it might be a mixture of organic matter and sand, or vermiculite or perlite, or you might have minerals in there. Whatever the mix is, as long as we understand the mix, we can make a curve for that, and then that can be published in IrriMAX Live and used for the next 10-20 years. Okay, thank you.